Now for part B, we've got to start with the interval then 1.4 to 1.5, where we know that there's a root that lies somewhere in between here. That's from the first part. And we've got to use interval bisection twice to find an interval of width 0.025 that contains this root alpha that makes f of x equals 0. So if we're doing the bisection method, first of all then we need to cut this interval in half. So for our first value of x, our first approximate value of x, we'll call it x1. We'll say x1 equals half of this interval here, which will be 1.45. And so we need to work out what we get, what kind of sign we get when we work out f of 1.45. Is it going to be positive or negative? So substitute 1.45 in for x. Cube it, minus 7 divided by 1.45 plus 2, and what you should find you get is 0.22103, and so on. So what this is showing us is that we've got a positive value when we take 1.45. Let's just put that in as 1.45. Now you can clearly see that my sketch here is now wrong because I've got at 1.45 the value would have been negative. So we now have seen that it is positive, so that tells us that the graph looks something like this, that as we come through here it was negative but it's now positive at this point, and something like that. So the root must lie now between 1.4 and 1.45. So let's just mark that in, that root alpha lies in the interval 1.4 to 1.45. So we've established that. We've done the bisection method once. Now we need to do it again. So what I need to do is cut this interval from 1.4 to 1.45 in half. So we're going to look at the midpoint of this. Let's just say that x2, our second value we're going to try, is going to be the mean then of 1.4 and 1.45. So 1.4 plus 1.45. Divide that by 2, that gives us the midpoint. What do we get? Well, it comes out at 1.425, and it's that value that we're now going to try and see what kind of sign we get. So if we do f of 1.425, substitute that then into here, you find that you get a negative number. That's the all-important negative number, 0.0186 and so on. So if we take this value at this midpoint here, my graph is showing that it is apparently negative at that point there. If we were to magnify that, because it's getting a little bit hard to see, okay, we've got that interval 1.4 and 1.425, and we see that it was already negative at this point here, the graph, and it's still negative at this point here. So we've got a graph coming up like this, and then it must obviously cross the x-axis between 1.425 and this point 1.45. So mark that in. We'll extend this axis here to 1.45. So hopefully you can see then that this root alpha must lie here somewhere in this interval because of the change in sign. So let's just come down here and we can say that therefore root alpha lies in the interval 1.425 to 1.45. 1.45, and you'll see that the width of that interval, if you were to subtract those two values, 1.45 and 1.425, you'll end up with 0.025, so a width of 0.025. And there you go. That should prove that answer.